Hi folks, this is DiffyQ Quiz 4. Given a bunch of Laplace transforms we're asked to find. And so this first one, we're asked to find the Laplace transform of t cubed. So the formula we're looking for here is the Laplace transform of t to the n power is n factorial over s to the n plus 1. And this formula is valid for all the whole numbers. So we're just applying the case when n equals 3. That gives me 3 factorial over s to the 3 plus 1, which gives me 6 over s to the 4th. In part B, we're looking for the formula Laplace transform sine of kt is k over s squared plus k squared. So here k is equal to 4, so it's 4 over s squared plus 4 squared, which is 4 over s squared plus 16. Part C, we're looking for the Laplace transform of e to the at, and that is 1 over s minus a. So here a equals 3. This is 1 over s minus 3. So those cover some of the basic formulas. Now, as we get into part D and E, we're going to have to use some of these other properties. So in part D, we have e to the minus t times cosine of 2t. And so we recognize that as applying the following. If you take the Laplace transform of e to the at times some f of t, where we know the Laplace transform of little f of t, this ends up being the Laplace transform of little f of t, but the s is replaced by s minus a. So basically it's a shift in the Laplace transform of little f of t. Now usually we write the Laplace transform of little f of t as big F of s, so this then is f of s minus a. So that's how we're going to handle this exponential. As far as the cosine is concerned, the Laplace transform of the cosine of kt is k over s squared plus k squared. And so our k here is 2, and we'll see how this all works out. So the first step is to take care of that exponential. So this is the Laplace transform of cosine of 2t, where we're going to shift s to s minus a. A in this case is a negative 1. So s minus a is s plus 1. So this is going to be s over s squared plus 2 squared in accordance with this formula. And I have to remember I need to shift the s. And so my final answer is s plus 1 over s plus 1 squared plus 4. Okay, for part E, we're looking at the Laplace transform of t times the sine of t. And we're going to use the derivative formula on a transform. If you take the Laplace transform of a power of t times some f of t, the result is negative 1 to the n times the nth derivative with respect to s of the Laplace transform of f of t. And so once again, if the Laplace transform of little f of t is denoted big F of t, then that's what you get. So that's going to take care of this power of t, and then the Laplace transform of sine of kt we've already seen, but I'll write it down again, is k over s squared plus k squared. So here the k is going to equal 1 for us. So this is equal to negative 1 to the first power times the first derivative with respect to s of the Laplace transform sine of t. So it's negative times the derivative with respect to s of 1 over s squared plus 1, which is negative. You go through your chain rule from Calc 1, negative 2s over s squared plus 1 quantity squared. And so it's 2s over the quantity s squared plus 1 quantity squared. So that'll do it for part E.